April 1944, Willow Run, Michigan. The roar is unrelenting. Every 63 minutes, another B-24 Liberator heavy bomber rolls off the assembly line. 4 engines, 67 feet of aluminum fuselage, 110 feet of wingspan, 18 tons of aircraft, complete and ready for war. The line never stops. Day shift, night shift, 7 days a week. The largest room ever built under a single roof, stretching nearly a mile in an L shape, producing what critics had said was impossible, a bomber an hour. Standing at the end of that mile-long line, watching another silver giant taxi toward the adjacent runway, a production supervisor checks his watch. 61 minutes since the last one. They're running ahead of schedule. 2 years earlier, this same plant was being mocked as Will It Run, a billion-dollar joke, a colossal failure of industrial hubris. The aviation world had laughed when Ford announced it would build complex heavy bombers on an automotive assembly line. You can't mass-produce aircraft like automobiles, they said. Too complicated, too delicate. Too many parts. The experts were certain precision aircraft required craftsmen's hands, not factory workers and conveyor belts. But in April 1944, Willow Run produces 428 B-24 Liberators in a single month. That's more heavy bombers than many nations built during the entire war. The plant that was supposed to fail is now producing half of all B-24s manufactured anywhere on Earth. The assembly line that was called impossible is now the beating heart of the arsenal of democracy, pumping out bombers faster than the Luftwaffe can shoot them down. The story of how Will It Run became the weapon that overwhelmed the Axis begins not in Michigan, but in a hotel room in San Diego, California, where one man spent a single night sketching an idea that would change the nature of modern warfare forever. It's the story of how American industrial might proved that wars are won not just with superior tactics or brave soldiers, but with superior production. And it begins with the realization that the aviation industry's most cherished beliefs were about to be shattered by a man who'd spent his life making cars. What he realized would change everything. If you want to see how this moment altered history, please hit that like button. It helps us share more stories like this. And subscribe if you haven't already. Back to that hotel room in San Diego where the vision began. January 1941, Consolidated Aircraft Corporation, San Diego, California. The nation wasn't yet at war, but President Roosevelt had already committed America to becoming the arsenal of democracy, promising to supply the Allies with 50,000 aircraft annually, more planes than had been built in total since the Wright brothers' first flight. Ford Motor Company executive Charles Sorensen arrived at Consolidated's facility to discuss manufacturing components for the B-24 Liberator bomber. Sorensen was no ordinary visitor. Known as Cast-Iron Charlie for his pioneering work in foundry techniques and mass production, he had spent 36 years transforming Henry Ford's visions into reality. He had designed the moving assembly line that revolutionized automobile manufacturing. He had overseen the production of 15 million Model Ts. He understood mass production better than almost anyone alive. What he saw at Consolidated Aircraft appalled him. Workers were assembling B-24s outdoors in the California sun on structural steel fixtures that expanded and contracted with temperature changes. There were no proper blueprints, just sketches and templates. Major components were custom-fitted by hand. Each aircraft was essentially unique, requiring individual adjustment and modification. A surveyor's transit sat on pallets in a pickup truck bed, used to manually align the propeller shaft. Hanging a single engine took 4 hours. Final assembly resembled the way Ford had built automobiles in 1905, before the assembly line existed. The B-24 was no Model T. It was a technological marvel. 4 Pratt & Whitney R1830 radial engines producing 1,200 horsepower each, twin tail fins, a wingspan of 110 feet, length of 67 feet. empty weight of 37,000 pounds, operational weight reaching 65,000 pounds. 2 bomb bays capable of carrying 8,000 pounds of explosives, 10 crew members, defensive armament of 10 50-caliber machine guns, maximum speed of 290 miles per hour with a range of 1,700 miles. The aircraft contained approximately 450,000 individual parts, connected by 360,000 rivets in 550 different sizes. It was the most advanced heavy bomber in production, designed to fly farther and carry more bombs than the B-17 Flying Fortress. And Consolidated was building them one at a time, like handcrafted furniture. Reuben Fleet, head of Consolidated Aircraft, took offense at Sorensen's barely concealed disdain. He asked Sorensen how Ford would do it better. That evening, Sorensen returned to his room at the Coronado Hotel and set to work. Throughout the day, he had taken copious notes. Every measurement, every assembly operation, Consolidated's labor force numbers, their production rates, their methods. Now, alone in his hotel room, he began breaking down the B-24 into its component assemblies and subassemblies. He listed every major unit, fuselage sections, wing assemblies, tail sections, engine mounts, landing gear. Then he broke those down further into subunits and fractional units. He computed the timing for each operation. He calculated the required floor space. He sketched the flow of materials and the progression of assemblies. Paper covered the floor of his room in separate piles, each representing a different unit of the aircraft. By 4 o'clock in the morning, he had arranged them in proper order, representing the most logical progress of units to a main production line. Standing over those piles of paper, he knew he could prove a construction rate of one big bomber every hour. He sketched his vision on Coronado Hotel notepaper, the floor plan of a bomber plant. It would be 1 mile long and 1/4 mile wide, the biggest single industrial building ever constructed. A mile-long machine that would build bombers the way Ford built automobiles, through the systematic movement of subassemblies converging on a main production line. The sketch, later initialed by Edsel Ford and others, became the blueprint for Willow Run. Ford didn't just want to build components for Consolidated to assemble. Sorensen convinced them to build complete aircraft, from raw aluminum to finished bomber, all in one location using pure mass production principles. In February 1941, the Army awarded Ford a contract to manufacture B-24 Liberators. Construction began immediately. The aviation industry watched Ford's ambition with undisguised skepticism bordering on contempt. These were automobile makers proposing to mass-produce the most complex machines ever built. The idea struck aviation executives as naive at best, dangerous at worst. "You can't expect a blacksmith to make a watch overnight," sniffed James Howard Dutch Kindleberger, president of North American Aviation. The quote captured the industry's attitude perfectly. Aircraft were precision instruments, requiring skilled craftsmen and careful hand-fitting. Each plane needed individual attention, custom adjustment, expert touch. Mass production might work for simple automobiles with 15,000 parts, but a bomber with 450,000 components? Impossible. The complexity would crash an assembly line designed for repetitive simplicity. Architect Albert Kahn designed the main structure, a man whose industrial buildings had revolutionized factory architecture. Construction proceeded at breakneck pace through 1941. The plant's L shape became necessary when engineers realized extending the building straight would place it across county lines, complicating tax arrangements, and would interfere with the adjacent airfield. A 90-degree turn solved both problems. By the time construction finished, the main building contained 3.5 million square feet of factory space. For perspective, Consolidated, Douglas, and Boeing's combined aircraft manufacturing space was less than Willow Run alone. The plant's dedication ceremony took place on June 16, 1941. Major Jimmy Doolittle attended, representing the U.S. Army Air Forces. Charles Lindbergh toured the facility, calling it a Grand Canyon of the mechanized world in his journal. The sheer scale was overwhelming. The building was so large it created its own internal weather patterns, moisture condensing on the ceiling and sometimes falling as mist inside the plant. Then came the hard reality of actually building bombers. The first aircraft was supposed to roll off the line in May 1942. It didn't emerge until September, a 4-month delay. Production in October 1942, 1 aircraft for the entire month. By early 1943, Willow Run had failed to meet any production target. The plant employed thousands of workers, but produced almost nothing. The problems multiplied. Consolidated Aircraft retained design authority and made constant changes, sometimes daily modifications that rendered Ford's expensive tooling obsolete before it could be used. Ford's 200 engineers worked in shifts around the clock, 7 days a week, creating proper blueprints from consolidated sketches and templates. They produced 5 miles of engineering drawings per day. 10,000 of the 30,000 drawings they completed were obsolete by the time they arrived back in Detroit from San Diego. The press, which had initially trumpeted Willow Run as proof of American industrial supremacy, turned vicious. Newspapers ran cartoons mocking the plant. The Detroit Free Press had prematurely boasted that Willow Run would build a bomber a minute by summer, an exaggeration that now looked like a cruel joke. Critics coined a new name for the facility: Will It Run? The nickname stuck, appearing in newspapers across the country. In Washington, Senator Harry S. Truman, chairman of the Special Committee to investigate the National Defense Program, took notice. The Truman Committee was charged with rooting out waste and inefficiency in war production. Willow Run looked like Exhibit A. Truman visited the plant in April 1942 and again in February 1943. He was unimpressed with Ford's explanations about Consolidated's interference. He didn't want excuses. He wanted finished bombers. Some in Congress talked about nationalizing Ford Motor Company and taking over Willow Run by government decree. The billion-dollar factory, the largest building on Earth, sat mostly idle. The assembly line that was supposed to crush the Axis produced almost nothing. The experts who had predicted failure felt vindicated. You can't mass-produce complex aircraft. Ford's blacksmiths couldn't make watches. But Charles Sorensen wasn't trying to make watches, he was building a machine that made bombers. The distinction mattered more than the critics understood. The aviation industry's approach to manufacturing was rooted in craft tradition. Each aircraft received individual attention. Skilled workers custom-fitted components. Measurements were adjusted by hand. This method worked fine for small-scale production. Consolidated had planned to build 1 B-24 per day and considered that ambitious. But Roosevelt wanted 50,000 aircraft per year. Craft methods couldn't scale to meet that demand. The mathematics were brutally simple. There weren't enough skilled aviation workers in the entire country to build aircraft one at a time at the rate America needed them. Sorensen understood that truly revolutionary production required a fundamental philosophical shift. Don't build aircraft like craftsmen, build aircraft like automobiles, through absolute standardization, specialized tooling, and systematic division of labor. The concept was called hard tooling. Instead of hand-fitting each part, create massive steel dies that stamp aluminum components to identical specifications every time. Instead of custom measurements, design fixtures that ensure perfect placement. Instead of skilled craftsmen custom-fitting major assemblies, design the assemblies themselves to be interchangeable, requiring only semi-skilled workers to bolt them together in predetermined sequence. This was harder with aluminum than with steel. Aluminum exhibited springback. After being stamped or formed, it tended to partially return to its original shape. Steel dies had to compensate for this property. The dies themselves were expensive to manufacture and couldn't be easily modified if the aircraft design changed. This was why Consolidated's constant design modifications proved so devastating. Each change required new tooling, new fixtures, new dies, hundreds of hours of engineering work, and hundreds of thousands of dollars of investment, junked with every modification Consolidated ordered. The Truman Committee investigation, despite its skeptical initial stance, eventually identified the real problem. The issue wasn't Ford's competence, it was divided authority. Consolidated Aircraft held final design control while Ford manufactured the aircraft. Consolidated could order changes at will, with no regard for the manufacturing disruption those changes caused. The committee recommended a single plant manager with complete operational authority over Willow Run, answerable directly to the Army Air Forces, not to Consolidated. That structural change, implemented in early 1943, transformed everything. With unified command, Willow Run's management could finally implement Sorensen's vision fully. The plant reorganized around the concept of modular subassembly construction. The fuselage was divided into sections: nose, forward fuselage, center fuselage, aft fuselage, tail. Each section had its own dedicated production line. The wings, the most complex component, incorporating the B-24's innovative Davis high aspect ratio airfoil design, were broken into center section and outer wing panels. Each had specialized fixtures and dedicated workstations. The center wing assembly became the masterpiece of the entire operation. All prefabricated structures were pre-manufactured to exact specifications. Workers didn't fit parts together, they assembled components designed to snap into place. Riveters worked in sequence along predetermined paths. Then the entire center wing assembly moved to a multiple function machine that completed 42 precision machining operations accurate to 0.0002 inch tolerance in 17 minutes. The innovation extended beyond the components themselves. The plant had to become a precision machine with thousands of moving parts, the workers and subassemblies themselves. Ford developed a sophisticated material handling system, conveyors, overhead cranes, turntables that allowed the 90-degree turn in the L-shaped building. The plant featured 4 large turntables 2/3 of the way along the assembly lines, allowing B-24 production lines to make the 90-degree turn while maintaining continuous motion. Training became systematic and intensive. The Aircraft Apprentice School could train 8,000 students per week, a complete production workforce every week if necessary. Workers learned specific, repetitive tasks designed to be mastered quickly. The goal wasn't to train aircraft craftsmen, it was to train specialized operators who could perform specific operations to exact specifications, over and over, all shift long. As men were drafted into military service, women filled their positions. By May 1942, 15% of Willow Run's workforce was women. They earned the same wages as men for identical work. The plant's workforce eventually peaked at 42,000, more than 3 times the entire population of Ypsilanti. Among them was Rose Will Monroe from Kentucky, a rivet gun operator who appeared in Ford promotional films and inspired the iconic Rosie the Riveter image that came to symbolize American women's contributions to the war effort. The plant developed supporting infrastructure unprecedented in scale: an on-site hospital, recreational fields, a dining hall serving thousands per shift. Thousands of buses ferried workers from Detroit and surrounding areas. Ford even built dormitories, eventually creating Willow Run Village to house workers. The housing shortage became so severe that some workers resorted to hot bedding, sleeping in shifts in the same bed their coworkers had just vacated. Practical problems required practical solutions. Some tasks required workers to crawl inside the bomber's wings to hold parts in place during assembly. Ford assigned workers of small stature to these positions. They could navigate the confined spaces more easily. By mid-1943, after reorganization under unified command, the assembly line began functioning as Sorensen had envisioned in that Coronado hotel room. The pace accelerated. The bugs disappeared. The machine started running. The transformation happened gradually, then suddenly. In October 1942, Willow Run had produced 1 aircraft for the entire month. By June 1943, monthly production reached double digits. By December 1943, the plant was producing over 150 bombers monthly. Then, in 1944, the machine truly hit its stride. January 1944, 228 aircraft. February, 250 aircraft. March, 336 aircraft. April 1944, 428 aircraft. The numbers represented more than statistics. Each number was a complete B-24 Liberator. 4 engines installed and tested, 2 bomb bays ready for ordnance, 10.50 caliber machine guns mounted, hydraulics, electricals, fuel systems all functioning, instrumentation calibrated. Each aircraft rolled from the final assembly position to the adjacent airfield, where test pilots conducted shakedown flights, checking every system before delivery to the Army Air Forces. The peak came in April 1944, when Willow Run achieved a production rate that silenced every critic: 428 bombers in a single month. Between April 24th and April 26th, just 3 days, 100 completed bombers flew away from Willow Run. The mathematical average worked out to 1 bomber every 63 minutes around the clock. The plant had achieved what Dutch Kindleberger said was impossible. The blacksmiths were making watches. The secret wasn't magic. It was systematic elimination of variation and waste. Every B-24 that rolled off Willow Run's line was identical to the one before it. Interchangeable parts meant interchangeable subassemblies, meant interchangeable complete aircraft. A wing from serial number 42-524363 would fit perfectly on serial number 42-524367 or 44-44052 or any other Willow Run Liberator. This standardization allowed rapid production, rapid repair in the field, and simplified logistics for an Air Force operating across 3 oceans and 6 continents. Employment, paradoxically, began declining even as production accelerated. At peak production in mid-1944, Willow Run employed only 17,000 workers, less than half the 42,000 employed during the troubled early period. The efficiencies Sorensen had promised finally materialized. Fewer workers producing more aircraft at lower cost per unit. Man-hours per bomber plummeted. Manufacturing costs dropped dramatically. The plant was producing aircraft so rapidly that the Army Air Forces couldn't absorb them all. In late 1944, the military ordered production reduced to 200 bombers per month. Storage facilities were full. Combat losses weren't as high as projected. American bombers were surviving missions at rates higher than expected. The Army literally told Ford to slow down because there was nowhere to park the bombers. By this point, Willow Run alone was producing more B-24s than the 4 other manufacturers combined. Consolidated's facilities in San Diego and Fort Worth, Douglas Aircraft in Tulsa, and North American Aviation in Dallas together produced 9,808 B-24s during the entire war. Willow Run produced 8,685. A single Ford facility matched the output of 4 traditional aircraft manufacturers. The contrast between 1942's Will It Run mockery and 1944's reality was stark. In 1944 alone, Willow Run produced nearly as many aircraft as the entire nation of Japan built that year. The plant that was supposed to fail had become Nazi Germany's nightmare, an unstoppable tide of bombers that couldn't be shot down fast enough to stem the flow. The B-24s rolling off Willow Run's assembly line entered service in every theater of World War II. Their contribution to Allied victory cannot be overstated. In the European theater, B-24 groups joined the 8th Air Force in England, flying daylight strategic bombing missions deep into Nazi-occupied territory. The Liberator's range exceeded that of the B-17, allowing it to reach targets in Eastern Europe and the Balkans that were beyond the Flying Fortress's reach. 21 bombardment groups of the 8th Air Force would fly B-24s at some point during the war. The 93rd Bomb Group became the first to fly combat missions in B-24s from England, beginning operations on October 9, 1942. These missions were brutal. Formation flying at 20,000 to 28,000 feet in unpressurized aircraft, temperatures dropping to 40 degrees below zero. Crews wore electrically heated suits and oxygen masks for missions lasting 8 to 10 hours. German fighters attacked from every angle. Anti-aircraft flak filled the sky over targets with black explosive bursts, accurate enough to shred aluminum fuselages. Each mission was a calculated gamble with death. August 1, 1943, Black Sunday, saw one of the most famous and costly B-24 missions of the war. Operation Tidal Wave sent 177 B-24s from bases in Libya on a low-level attack against the oil refineries at Ploiești, Romania. The refineries produced one-third of German oil and aviation fuel, making them a priority target. 5 bombardment groups participated: the 44th, 93rd, 98th, 376th, and 389th. The plan called for a low-level attack to achieve surprise and maximize accuracy, with aircraft flying at treetop level to evade radar detection. The mission began before dawn on August 1st. The formations flew 1,350 miles across the Mediterranean, threading through valleys in the mountains of Yugoslavia and Bulgaria. Navigation errors caused some groups to miss their initial points. Surprise was lost. German defenders were waiting. The B-24s pressed their attacks anyway, flying through walls of anti-aircraft fire at altitudes under 300 feet. Some bombers struck refinery stacks and chimneys, disintegrating on impact. Others flew through fireballs from bombers hit ahead of them. The refineries became infernos, with flames reaching hundreds of feet into the air. 54 B-24s were lost, nearly one-third of the attacking force. Of 1,726 crewmen, 532 died, 504 were interned in neutral Turkey after crash landing there, and 108 became prisoners of war. 5 medals of honor were awarded for the mission, 3 posthumously. But the strategic impact justified the cost. Ploiești's refining capacity was severely damaged, forcing the Germans to rely on increasingly scarce synthetic fuel production. Follow-up raids continued through 1944, eventually reducing Ploiești's output by more than 40%. In the Pacific Theater, B-24s served in the longest-range bombing missions ever flown. Operating from bases in Australia, New Guinea, and eventually the Philippines and the Marianas, they struck Japanese targets thousands of miles away. The 5th Air Force, under General George Kenney, deployed multiple B-24 groups across the Southwest Pacific. The 7th Air Force operated Liberators in the Central Pacific Campaign, striking targets in the Marshall Islands, Caroline Islands, and eventually the Japanese home islands themselves. The distances involved staggered imagination. Missions from Australia to targets in the Netherlands East Indies covered 2,000 miles or more. Crews flew for 12 to 14 hours, much of it over open ocean, where a mechanical failure or navigation error meant certain death. There were no emergency landing fields in the middle of the Pacific. Engine failure meant ditching in shark-infested waters, hoping rescue aircraft or submarines could find you before exposure, dehydration, or predators finished you. On April 18, 1943, 16 P-38 Lightnings intercepted Admiral Isoroku Yamamoto's transport aircraft over Bougainville, killing the architect of Pearl Harbor. The mission's success depended on intelligence provided by American cryptanalysts who had broken Japanese naval codes, and long-range navigation made possible by B-24-based photo reconnaissance flights that had mapped the area in previous weeks. Yamamoto's death dealt a devastating psychological blow to Japanese morale. The Navy and Coast Guard acquired 977 B-24s, designated PB-4Y1, operating them in both Atlantic and Pacific waters. These maritime patrol variants were modified with additional fuel capacity and specialized equipment for anti-submarine warfare. PB-4Y1s destroyed 93 German U-boats in full or in part. The sudden turn of the Battle of the Atlantic in May 1943 resulted partially especially from the arrival of very long-range Liberators capable of patrolling the mid-Atlantic Gap, where U-boats had previously operated beyond the range of land-based aircraft. The Royal Air Force operated B-24s extensively, while RAF Bomber Command didn't use them for strategic bombing over northwest Europe, preferring the Avro Lancaster for that role. RAF Coastal Command deployed Liberators for maritime patrol. In the Middle East and Southeast Asia, RAF squadrons flew Liberators on bombing missions, transport operations, and electronic warfare missions. Modified Liberators carried jamming equipment to counter German radar. The Royal Australian Air Force received 287 B-24s of various models, operating them primarily from bases in Northern Territory, Queensland, and Western Australia. They conducted bombing raids against Japanese positions in New Guinea, Borneo, and the Netherlands East Indies. More than 200 Australians died in B-24 operations, with 33 aircraft lost to combat or accidents. But the true measure of Willow Run's contribution wasn't just the aircraft themselves, it was the industrial capacity those aircraft represented, the demonstration that American manufacturing could overwhelm any opponent through sheer productive volume. In 1944, the United States produced 96,318 aircraft of all types. Germany produced 40,593. Japan produced 28,180. The Soviet Union, despite its massive industrial mobilization, produced 40,246. The United States alone outproduced Germany and Japan combined by more than 30,000 aircraft. Willow Run's B-24s represented a significant portion of that production. The psychological impact on the Axis powers was devastating. Hermann Göring, commander of the Luftwaffe, had laughed in 1940 when Roosevelt announced plans to produce 50,000 aircraft annually. He called it propaganda. By 1944, faced with American bomber formations numbering hundreds of aircraft attacking German cities in daylight, while RAF Bomber Command attacked at night, Göring's Luftwaffe was broken. Not destroyed in combat, destroyed by attrition. For every bomber shot down, 3 more arrived from American factories to replace it. Production at Willow Run ceased on June 28, 1945. The last B-24 Liberator rolled off the assembly line, completing a production run that had lasted from September 1942 to June 1945. Total production, 8,685 aircraft, 6,792 complete bombers, and 1,893 knockdown kits for assembly at other facilities. The variants produced at Willow Run included nearly every model of the Liberator family. The B-24E was the first variant primarily manufactured at the plant. 490 complete aircraft plus component kits. The B-24H introduced a powered nose turret and improved bomb sight. Ford built this variant alongside Consolidated and Douglas. The B-24J, considered the definitive Liberator, entered production in August 1943. All 5 major manufacturers switched to this standardized version. The B-24L and B-24M were lighter weight variants with reduced defensive armament, built primarily at Willow Run as the war wound down. The B-24 became the most produced American military aircraft in history, 18,493 total built by all manufacturers. Willow Run alone accounted for nearly half that total. By comparison, Boeing produced approximately 12,731 B-17 Flying Fortresses, an impressive number but substantially less than B-24 production. The human cost of B-24 operations was substantial. Thousands of American, British, Canadian, Australian, and other Allied aircrew died in Liberators. The 8th Air Force's bomber crews suffered approximately 26,000 killed in action, with losses distributed across both B-17 and B-24 groups. Pacific Theater B-24 crews faced different dangers: long overwater flights, tropical diseases, Japanese fighters, and anti-aircraft fire. After the war ended in August 1945, the United States found itself with thousands of surplus B-24s. Most were flown to storage facilities in Arizona and other locations with dry climates. Of the 18,493 Liberators built, only a handful survive today. 13 are known to exist worldwide, 10 on display in museums, 1 under restoration, and 2 maintained in airworthy condition. The Collings Foundation operates one of those airworthy examples, touring it across the United States as part of the Wings of Freedom tour, giving Americans the opportunity to see, touch, and even fly in a restored B-24. Ford Motor Company chose not to exercise its option to purchase the plant after the war. Kaiser Frazer Corporation took over the facility in 1947, producing automobiles including the Kaiser, Frazer, and Henry J. In 1953, Kaiser Frazer left Michigan. General Motors purchased the plant and produced transmissions there for decades, later adding automobile assembly, including the Chevrolet Corvair and Nova. GM closed Willow Run in 2010 during bankruptcy proceedings. Most of the facility was demolished in 2014, but the Yankee Air Museum acquired 175,000 square feet, the final assembly area where completed B-24s rolled toward the runway, preserving it as a museum to commemorate the plant's role in winning World War II. The plant's ultimate legacy extends beyond the aircraft it produced. Willow Run proved that even the most complex machines could be mass-produced using systematic methods. The Toyota production system, later known as just-in-time manufacturing and lean production, traces direct lineage to the techniques Charles Sorensen pioneered at Willow Run. The plant demonstrated that industrial capacity itself is a weapon, perhaps the most decisive weapon in modern warfare. April 1944, Willow Run, Michigan. Another B-24 Liberator rolls off the assembly line, 63 minutes after the one before it. The line never stops. The critics who mocked Ford's ambition in 1941 had been catastrophically wrong about one fundamental issue. They believed aircraft were too complex for mass production. They were right that aircraft were complex. They were wrong about the conclusion they drew from that complexity. Complexity doesn't prevent mass production. Complexity requires mass production. When you need thousands of aircraft, tens of thousands, eventually 18,000 B-24s alone, craft methods cannot scale. Individual artisanship becomes a bottleneck. The only solution is systematic division of labor, standardized components, specialized tooling, and assembly line methods. The craftsman's approach may produce beautiful individual aircraft, but it cannot produce them in numbers sufficient to overwhelm an industrialized enemy. The lesson of Willow Run extended far beyond aircraft manufacturing. It demonstrated the fundamental importance of industrial capacity in modern warfare. Nazi Germany possessed superior tank designs in many respects. The Tiger and Panther were arguably better tanks than the Sherman, but the United States produced 49,234 Sherman tanks. Germany produced approximately 6,000 Tigers and Panthers combined. Superior design loses to superior production when the numerical advantage becomes overwhelming. The same principle applied in the air. The Luftwaffe possessed skilled pilots, sophisticated tactics, and well-designed aircraft, but pilot skill and tactical sophistication matter less when facing a 3-to-1 numerical disadvantage. For every Luftwaffe fighter that shot down an American bomber, the American aircraft industry produced 3 more bombers. Germany couldn't sustain that exchange rate. Their industrial base, hampered by Allied bombing and shortages of critical materials, couldn't match American output. The war became a contest of attrition, and attrition favors the side with deeper reserves. Willow Run represented the vindication of Charles Sorensen's vision. The sketch he drew on Coronado Hotel notepaper in January 1941 became reality, a mile-long machine that built bombers. Not craftsmen building aircraft one at a time, but a systematic process that transformed raw aluminum into finished bombers through thousands of specialized operations, each performed by semi-skilled workers who mastered specific tasks. The philosophical difference between Ford's approach and the aviation industry's traditional methods illuminated a deeper truth about industrialization itself. Traditional craft methods emphasize individual skill, flexibility, and custom fitting. Industrial methods emphasize standardization, specialization, and interchangeability. Both approaches have merit in different contexts. For small-scale production, craft methods work well. For mass production, industrial methods become essential. The error the aviation industry made was assuming their craft methods could scale to meet wartime demands. They couldn't. Ford's industrial methods could and did. The nickname "Will It Run" became a historical footnote, remembered only as ironic foreshadowing. The factory didn't just run, it ran faster, more efficiently, and at greater scale than any aircraft manufacturing facility ever built. The blacksmith didn't make watches. The blacksmith built a watch factory that produced watches faster than anyone thought possible. The examination of Willow Run's transformation from mockery to miracle reveals a truth about innovation and industrial progress. Revolutionary ideas face skepticism not because they're wrong, but because they challenge established beliefs and methods. The aviation industry's skepticism wasn't baseless. They understood aircraft complexity intimately. What they failed to understand was that their traditional methods, however effective for small-scale production, represented a bottleneck that systematic industrial methods could eliminate. In the end, the aircraft that couldn't be mass-produced became the most produced American military aircraft in history. The factory that would never work produced nearly half of all B-24s manufactured worldwide. The assembly line that couldn't build complex aircraft built them faster and cheaper than traditional methods ever could. And the skeptics who said Ford's ambition would fail learned a lesson that echoes through industrial history. Never underestimate the power of mass production when properly applied. The B-24s of Willow Run helped win World War II. But the true victory wasn't just in the aircraft themselves. It was in the demonstration that American industrial capacity, properly mobilized and systematically applied, could overwhelm any enemy through sheer productive volume. The factory became the weapon, the assembly line became the strategy, and mass production became the means by which democracy defended itself against totalitarianism. That lesson, first sketched on hotel notepaper in a single night of furious calculation, remains relevant today. Modern conflicts still hinge partially on industrial capacity. Supply chains, manufacturing infrastructure, and productive volume still matter. The specifics change: semiconductors instead of aircraft, precision munitions instead of carpet bombing, but the fundamental principle endures. Wars are won not just on battlefields, but in factories. The plant that was mocked as "Will It Run" answered that question definitively. It ran brilliantly, it ran faster than anyone predicted, and it ran long enough to help crush the Axis powers beneath an avalanche of American industrial might. The largest factory on Earth proved that in modern warfare, production capacity itself is victory. Everything else is commentary.